Hello, welcome to OmniCNS. I am Yinja Lim, the head of the Education and Research Center at OmniCNS. It's nice to meet you. Now, in this session, we will take a look at the OmniFit Mind Care Interpretation Manual. First, this is the Mind Care Professional Guide. At OmniCNS, we measure the pulse wave, which reflects the autonomic nervous system, and the brain wave, which reflects the central nervous system. First, we will look at the results of the pulse wave measurement, and then we will move on to the results of the brain wave measurement. The indicators from the pulse wave measurement results will cover heart health, physical stress, accumulated fatigue, physical vitality, autonomic nervous system health, autonomic nervous system balance, and the activity levels of the sympathetic and parasympathetic nerves. Secondly, in the brainwave measurement results, we will look at the basic sound, brain waves, brainwave power, brain workload, which shows how much strain is placed on the brain when it is performing certain tasks, mental stress, concentration, imbalance between the left and right hemispheres, intrinsic rhythm, and peak frequency. As I mentioned earlier, let's take a look at the first result from the pulse wave measurement, which is HRV healthly or heart health. Heart health is related to the variation in intervals between heartbeats, as well as the balance of the autonomic nervous system that controls the heartbeat. The autonomic nervous system causes the intervals between heartbeats to change in real time in response to external stimuli. What happens when we suddenly get nervous or startled? You can feel your heart pounding, right? At times like that, your heart beats faster, and when you're relaxed, it beats more slowly, so we look at the changes in the intervals between heartbeats. Now, when our heart beats and pumps blood out through the vessels, it generates a special graph, which is known as the PQRST wave, representing the electrical activity of the heart. At that time, we analyze heart health using the RR interval, which is the interval between the peaks of the heartbeats. Therefore, if the intervals between heartbeats are regular, for example, 700, 710, 700, or 720 milliseconds, and the heart beats in a consistent pattern, then, as shown in the diagram below, the curve doesn't vary much and forms a graph that's almost a straight line. Also, in the case of the graph below, the intervals between heartbeats are quite short. In other words, it means the heart can't quickly respond to external stimuli. However, when the heart reflects these external stimuli in real time, yes, like the graph above, the intervals between heartbeats become somewhat uneven and irregular, creating an aerobic, rhythmic curve. In this case, the heart is considered to be even healthier. As you can see here, the x-axis, or the horizontal axis, represents the values when the heart beats, and the y-axis shows the intervals between the timing of each heartbeat. When the amplitude is large and the curve is aerobic like this, it indicates an even healthier state. Therefore, when the intervals between heartbeats are irregular, we can consider the heart to be even healthier. On the other hand, if the intervals between heartbeats are almost always regular, you might have seen on TV sometimes where the atria beat in a very steady pattern, right? Yes, even if it's not exactly like that, when the heartbeat is not very irregular and beats at a constant interval, later on, when you look at the histogram, the bar graph will also look almost like a straight line, like telephone poles. In this case, If someone gives you a little nudge from the side, you could just collapse right away. In other words, in these cases, your ability to cope with external stress or situations also decreases. Also, in such cases, if our heart is not healthy, we need to be cautious because there could be a risk of sudden cardiac death. Yes, next is a histogram representation of the heart rate variability, or the changes in the intervals between heartbeats, which you saw earlier. In this histogram, as you can see, the x-axis at the bottom here represents the intervals at which the heart beats, and the y-axis shows the number of heartbeats. As you can see, when there are differences in the intervals and the heartbeats in a varied and irregular way, the graph forms a bell-shaped curve like this. However, if the intervals between heartbeats become regular, as you can see, the beats occur almost at the same position without any time difference. It's just like a row of utility poles. In this situation, just like in the previous illustration, if someone gives it a strong push from the side, it could easily topple over. But in the case of the graph above, it would stay strong and not collapse even with a fair amount of stimulation. So when the histogram is wide and forms this kind of bell shape, we can consider it a healthy state. Therefore, as shown here, the lower the height of the graph and the wider its area, the healthier the state is considered to be. If a graph like the one below, which represents an unhealthy state of consciousness, appears as I mentioned earlier, yes, the risk of sudden cardiac death can be very high. Yes. Next, let's talk about physical stress as seen through the autonomic nervous system. This stress can be assessed based on autonomic nervous system measurement data. To make it easy for the general public to understand, we've also displayed it in the form of a bar graph so it can be seen intuitively. Again, when it comes to physical stress, yes, the lower it is, the better. That's right. So when it's below the appropriate level, that's considered the healthiest state. So we check the level of physical stress by looking at the ratio of the sympathetic and parasympathetic nerves, as well as the activity of the parasympathetic nervous system. Therefore, the lower that value is, the less physical stress you're experiencing and the healthier you are. However, if these values are high, you'll start to feel psychological discomfort like tension, anxiety, stress, or restlessness, and as a result, that's what happens to us. You might experience indigestion, have trouble digesting food, or sometimes get headaches for no apparent reason. Yes, you can show these kinds of physical reactions. In these cases, people often end up going to the hospital. I have a headache and I need to go to the hospital. My head feels heavy. I have trouble digesting food. So when you go to the hospital with these symptoms, sometimes they can't find any specific cause. In those cases, the hospital might say it's due to stress. Yes. So when it comes to the autonomic nervous system, it's very important to maintain a healthy state by keeping a balance between the activity of the sympathetic and parasympathetic nerves. Next, let's talk about accumulated fatigue. When we experience repeated stress, if that stress keeps building up, we start to feel cumulative fatigue. So our bodies also start to feel that kind of fatigue. And when accumulated fatigue builds up a lot, what happens to you? You try to do something, but your body just won't cooperate. That happens quite often, right? In those cases, it could mean that your accumulated fatigue has become excessive. So when it comes to accumulated fatigue, it's important to manage it well through changes in your daily life. As expected, the lower your accumulated fatigue score, the less fatigue your body has built up and the healthier you are. So, If you have almost no accumulated fatigue, we can consider that a healthy state. However, if this accumulated fatigue builds up too much, it leads to stress, and as a result, the physical fatigue we discussed earlier also increases. Of course, the function of the autonomic nervous system will also be weakened. As a result, your immune system will be compromised. This is in line with the histogram we looked at in the previous section. In other words, when accumulated fatigue builds up, our ability to quickly react and respond in real time to external stimuli decreases. As a result, your immunity drops, and you may find yourself catching colds more often or showing similar tendencies. And you'll also become very vulnerable to external environments. So even with small things, you might react sensitively or perceive them as strong stressors. As a result, your ability to cope with stress will be weakened. Yes, next is physical vitality. Physical vitality reflects the current state of your body's energy and lethargy. The autonomic nervous system responds very quickly in real time to external stimuli and information from the environment. This autonomic nervous system and its level of activation can show changes even just by taking a deep breath during the measurement. The current state, meaning the real-time response to certain stimuli, can be quickly seen through these indicators of the autonomic nervous system, and physical vitality also reflects this kind of state. The closer you get to the physical vitality stage, in other words, the closer you are to the vitality level, the healthier your body is considered to be. All of these indicators are assessed based on the ratio between the sympathetic and parasympathetic nervous systems. The closer you are to the physical vitality index, the healthier your state is considered to be. Generally, healthy young adults tend to have values that are closer to the healthier range. However, for older adults, middle-aged people, and seniors, if they exercise regularly or if their autonomic nervous system is in a healthy state, their indicator values also come out closer to the physical vitality index. So, generally, this physical vitality is higher during the daytime, especially in the morning, when we are more alert and awake, and it's the time of day when we need to be active, right? That's why it's better for your vitality to be higher during these times. But yes, I am very energetic even in the evenings. Then what do you think will happen? That's right. It might be difficult to get a good night's sleep. Yes, it might even get to the point where you feel like you need to go out and move around at night. So in the evening, it's actually better if your vitality is a bit lower than usual, or at least not too high. That way, we can get a good night's sleep. Also, generally in the afternoon or late afternoon, after a whole day of work, when you're already tired, your physical vitality tends to drop a bit lower. This level of physical vitality, yes, also changes depending on the activity of your sympathetic and parasympathetic nervous systems. In the morning, when we're alert, awake, active, and need to process a lot of information, it's generally better for the sympathetic nervous system to be more active than the parasympathetic nervous system. And in the afternoon, the activity of the parasympathetic nervous system tends to become a bit higher than that of the sympathetic nervous system. That's generally the case, and in the evening, when the activity of the parasympathetic nervous system is somewhat higher, we can enter a comfortable, deep sleep. However, sometimes people fall into states of extreme hyperactivity or lethargy. In other words, This could mean that the balance of the autonomic nervous system is disrupted. When the sympathetic nervous system is excessively overactive, you may experience tension, anxiety, restlessness, and become extremely sensitive to external environments. On the other hand, when the parasympathetic nervous system is excessively overactive, yes, it can be too much as well. You feel weak physically. Your energy level is so low that you can even fall into a state of lethargy. So, when you try to do something, you just don't have the strength. Yes, in such cases, depression can sometimes accompany these symptoms. However, this kind of state can also be temporary. For example, during exam periods. It's a situation where you're suddenly exposed to strong external stress that really stimulates you. In those cases, your sympathetic nervous system can become overactive. And so tired again. Maybe you worked way too much yesterday and barely got any sleep. In these situations, excessive fatigue can also cause your parasympathetic nervous system to become overactive. However, if those conditions persist, the balance of your autonomic nervous system can be disrupted, which may lead to autonomic nervous system dysfunction. Now, let's talk about the health of the autonomic nervous system. When it comes to the autonomic nervous system, we always look at the activity levels of both the sympathetic and parasympathetic nerves. So, by reflecting the overall activity of the sympathetic and parasympathetic nerves, it shows the body's overall vitality and functional state. Therefore, we assess the health of the autonomic nervous system by looking at the activity levels of the sympathetic and parasympathetic nerves, as well as the total power of both. Again, the closer these values are to the higher end of the appropriate range, the healthier the state is. Therefore, when the health of the autonomic nervous system is low, that is, when the activity of both the sympathetic and parasympathetic nerves is low and the total power value is also generally low. In such cases, you may experience chronic fatigue and a decrease in immunity. As I mentioned earlier, your ability to cope with external environments may be reduced. Of course, your ability to handle stress will also decrease. In these cases, you might be exposed to chronic stress, or it could be a state where fatigue keeps accumulating due to ongoing tiredness. In this case, yes, you may show symptoms like depression and lethargy, and it can also be an indicator that your overall autonomic nervous system health is not good. So, when the health of your autonomic nervous system deteriorates and your sympathetic nervous system becomes overactive, your body can become weak and extremely sensitive. So, even to the smallest stimulus, you might react excessively sensitively, or you may often feel irritable. These kinds of tendencies can appear. Also, when the health of your autonomic nervous system is very poor and your parasympathetic nervous system becomes even more overactive, you may end up feeling lethargic, wanting to do something or take action but being unable to do so. That's why it's important to maintain and manage the health of your autonomic nervous system well. And if your health is good, as I mentioned earlier, the levels of activity between the sympathetic and parasympathetic nervous systems stay balanced, constantly trying to maintain a steady state. This is what we call homeostasis. When homeostasis is maintained, the overall level of activity is also high and functions well. So in this case, of course, both your mental and physical coping abilities will be very good. Your immune system will also be strong. Now, next is the autonomic nervous system balance chart. As I've mentioned several times before, The most ideal state for the autonomic nervous system is when the sympathetic and parasympathetic nerves are in balance. Like this. So, the most ideal situation is when the activation of the sympathetic and parasympathetic nerves is balanced. Of course, there can be temporary situations, like a very stimulating reaction from an external source, or if you were extremely fatigued the day before, stayed up all night, drank too much, or had an upset stomach. Of course, in these cases, the balance gets disrupted. However, if this kind of state continues for a long time, as I mentioned earlier, your autonomic nervous system health can become very poor. So, having a balance between the sympathetic and parasympathetic nerves is considered the healthiest state. That's what it is. Now, if the balance is disrupted and the sympathetic nervous system becomes excessively activated, yes, it would feel like we're constantly tense and anxious, with our hearts pounding so hard that you could even feel it from the outside. When that happens, your blood pressure rises, and because your blood pressure shoots up quickly, your face might turn red and you might start sweating, and so on. And even the smallest external stimulus can make you irritable, angry, or overreact, so you can easily be exposed to feelings of rage. As I just mentioned, these things can sometimes happen due to temporary stimuli. However, if these conditions persist for a long time, they can increase the risk of developing heart diseases such as arteriosclerosis or myocardial infarction. Therefore, we need to manage these things well. Yes. And when the parasympathetic nervous system is excessively activated. Yes. In these cases, of course, if it's generally activated to maintain balance or just slightly elevated, you could say the body is in a relaxed state. However, if those conditions are maintained for a long time, our overall functions, like temperature regulation or the activity of internal organs related to the autonomic nervous system, could decrease. And because the body can't respond properly, it can also lead to disorders like irritable bowel syndrome. Also, when this lowered state persists excessively, we might experience symptoms like orthostatic hypotension. If this overactive parasympathetic state continues for a long time, it can lead to lethargy and depression. So, the balance of the autonomic nervous system is shown as a bar graph like in the picture above, displaying the sympathetic and parasympathetic nerves, as well as the total power value. It's also shown as a pie chart, and in this current state, the sympathetic nervous system is overactive. Yes. It's important that this balance is not excessively disrupted like this. Yes. And of course, this is something I've mentioned repeatedly, but still, it's important. If this kind of overactive state of the sympathetic nervous system continues, when the sympathetic nervous system is heightened, the neurotransmitter called adrenaline is released in a burst. Normally, this adrenaline is used up again within about 90 seconds, and then the parasympathetic nervous system becomes more active and releases acetylcholine. So, when the sympathetic nervous system spikes, the parasympathetic should also rise to maintain balance, but if the sympathetic nervous system becomes overactive, the parasympathetic can't keep up. In other words, before all the adrenaline is used up within 90 seconds, it keeps being released over and over again. When that happens, we keep burning through our energy, so we end up feeling exhausted. Yes. All right, next is the activity of the sympathetic nervous system. The sympathetic nervous system is said to be activated when the body is in a state of alertness. As I mentioned earlier, when external stimuli make us uncomfortable, we become even more tense, and when those external stimuli are perceived as stress, the sympathetic nervous system becomes even more activated. That's why we end up using up our energy. So, it's ideal for the activation level of the sympathetic nervous system to be at an appropriate level rather than being too low or too high. Therefore, when the sympathetic nervous system is excessively activated, as I briefly mentioned earlier, the overall results show that healthy people are in a comfortable and stable state. But when the activation levels of both the sympathetic and parasympathetic nervous systems are low at the same time, yes, in that case, yes, that's right. It means that the overall ability to regulate the autonomic nervous system is reduced. So, you become more vulnerable to stress. Also, if the parasympathetic nervous system's activation is normal but the sympathetic nervous system's activation is low, in this case, you feel weak. You try to do something, but it just doesn't work out. So, it can lead to lethargy or even dizziness. On the other hand, when the sympathetic nervous system is highly activated, there can be temporary overactivity, as we mentioned before. When you have to take a test, or when someone suddenly gives you some bad or shocking news. In these situations, your sympathetic nervous system can become temporarily overactive. However, if this heightened sympathetic activity continues for a long time, it can lead to chronic stress, sleep disorders, and a decrease in the activity of your immune system. Next is the activity of the parasympathetic nervous system. The activation of the parasympathetic nervous system is generally associated with us being in a comfortable, relaxed, and stable state. That's another way to look at it. When the parasympathetic nervous system is active, it releases a neurotransmitter called acetylcholine, and in general, we know that the activation of the parasympathetic nervous system helps conserve energy. So, you might think that having high parasympathetic nervous system activity is good, but just like before, having excessively high activity is not ideal either. Therefore, we can say that maintaining the activity of the parasympathetic nervous system at an appropriate level is the healthiest state. Now, let's talk about cases where the activity of the parasympathetic nervous system is low. If you have severe chronic fatigue, you might not be able to tolerate cold, and you may also experience lower blood pressure and pulse rate. Also, when the activity of the parasympathetic nervous system drops too much, the decrease in lymphocytes can make you more vulnerable to bacteria and viruses, so you might catch colds more often, and things like that. You may also become more susceptible to infectious diseases. On the other hand, if the activity of the parasympathetic nervous system is excessively high, in other words, if it's overactive, it can cause symptoms like fatigue, lethargy, and even depression. Therefore, the most ideal situation is for the sympathetic and parasympathetic nervous systems to maintain a proper balance and keep homeostasis. If the sympathetic nervous system becomes overactive, the parasympathetic system should also become more active to bring things back down. Yes, this kind of state can be considered the most ideal. Next, let's take a look at the results of the EEG measurements. First, let's look at the basic brainwaves in the EEG results. Here, the EEG results we will look at are the brainwaves that appear when the brain is in a basic state, meaning when your eyes are closed, you are relaxed and calm, and there is no external stimulation, also known as the boat mode state. Brainwaves can largely be divided into spontaneous brainwaves and evoked brainwaves. The basic brainwaves I mentioned earlier, that is, brainwaves in a state where there is no external stimulation, are called background brainwaves. So, we observe the brainwaves that appear when the brain is in a somewhat idle or lazy state, in other words, in an idling state. Evoked brainwaves are those that are triggered by providing some kind of external stimulus. So, evoked brainwaves are measured when an external stimulus is introduced and the brain processes that information. We will be looking at spontaneous brainwaves, that is, background brainwaves. As I mentioned earlier, we observe spontaneous brainwaves in a relaxed state with eyes closed, where there is no external stimulus. So, when we measure brainwaves, as you can see, we extract indicators for theta, alpha, low, mid, and high beta, as well as gamma power. Theta power generally refers to frequencies from 0 to 4 Hz. Yes, and just below that, we have delta waves. Delta power refers to frequencies from 0 to 4 Hz. Generally, when we are conscious and awake, the amount of delta power present is very low, so here we don't look at delta power and instead start extracting indices from theta power. Typically, theta power is said to reflect a state of unconsciousness. It tends to appear predominantly when you're a bit drowsy or in deep meditation. Also, in infants and young children, theta power is the dominant frequency, meaning it's the frequency that appears most prominently. Next is alpha power. Alpha power corresponds to a frequency of about 8 to 12 Hz, and for healthy adults, it's also the most dominant frequency. That's why we sometimes refer to it as the intrinsic rhythm for healthy adults. Generally, alpha power appears most prominently when you're relaxed and at ease, and it's said to be associated with creative thinking. Next is beta power. Beta power typically refers to frequencies ranging from 12 to 30 Hz. Of the three subdivisions, low beta refers to frequencies from 12 to 15 Hz. Typically, low beta appears most prominently when you're in a stable state, focusing your attention and feeling alert. In other words, you could call it a relaxed yet focused state. And mid beta refers to frequencies from 15 to 20 Hz, and it appears predominantly during learning or cognitive activities. This frequency also appears predominantly during periods of concentration, and generally, when the frequencies from low beta to mid beta are dominant, it means learning happens best in a relaxed and comfortable state. In other words, it's when concentration is at its highest. Next is high beta. High beta refers to frequencies between 12 and 30 Hz. This high beta frequency also appears predominantly during states of alertness, tension, anxiety, and stress. Of course, it's also a frequency that becomes dominant when we're studying or working on something. Next, gamma power refers to frequencies above 30 Hz, and it is said to be dominant during states of high alertness when you need to intensely concentrate to solve a math problem in situations requiring advanced cognitive functions and also during deep meditation. So, there are research papers that report both gamma power and theta power are predominantly present during deep meditation. There are research findings from studies on Tibetan monks showing that when they enter deep meditation, both theta power and gamma power become dominant. Next is the band power trace. In other words, it's the brainwave power. This allows you to see, in real time, the flow of brainwave power in each frequency band while measuring the brainwaves. Even just by looking at this graph, you can see the state of this person's brainwave frequency power during the 1-minute measurement. In other words, in the given image, the alpha power is positioned right at the top, and the other frequencies are synchronized and appear well aligned together like this. This is the most ideal form. However, sometimes theta power appears predominantly, or high theta may show up dominantly along this line. When you squint your eyes or blink, the theta power frequency can sometimes appear here in a dotted pattern like this. In those cases, by looking at the measurement results, you can say, during this period, you blinked your eyes a lot at this spot. Or maybe you found a lot. You can figure out things like this. Also, when you're exposed to strong stress, sometimes the high beta power can be positioned higher than the alpha power like this. So, when you blink your eyes or move your body a lot, if the theta power suddenly spikes like this, it could mean that noise has been introduced, so in these cases, it's necessary to take the measurement again. Also, if the alpha power is sitting nicely at the top line like this, but suddenly the alpha power drops sharply and the theta power becomes dominant and stable, it could mean that you briefly dozed off during the measurement or something similar happened. In that case, yes, the examiner can watch from behind and remind the subject by saying something like, "Please don't fall asleep." Right. So, as I explained earlier, it's most ideal for the alpha power to appear stably at the highest level. And as high beta continues to appear at elevated levels, of course, it could mean the person is in an unstable state or perhaps exposed to some kind of stress, or when the brain is experiencing a very uncomfortable emotional state, high beta can also become dominant. Yes, next is the brain load chart. The brain load chart shows that even when your eyes are closed and you're in a relaxed state, your brain can't fully enter a comfortable, relaxed, resting mode. It's like a car engine idling. Your brain keeps running, caught up in thoughts or staying active. You can see this state. So, the value of the brain load chart is determined by what we call the spectral edge frequency 90, which is based on the principle that it represents 90% of the total area of the power spectrum. Likewise, it's ideal when the value of the brain load chart is at an appropriate level. However, if the brain load value is excessively low, if the numbers are very low, it can also indicate that the brain activity is low. We also use the value of the spectral edge 90 as an indicator to check the anesthesia state during surgery. It also serves as an indicator of the brain's level of activity. So, if this value appears excessively low, it could indicate extreme overwork or fatigue. In other words, a state where brain activity is very low. When such a state is maintained over a long period, it can also be accompanied by symptoms like lethargy or depression. On the other hand, when this SEF 90 value is very high, it means that even though the brain should be resting, it keeps processing information like a car engine idling. For example, let's say a child gets into a fight with a friend at school or is attacked by a group of friends. Even in that case, those thoughts keep coming up in your mind, even when you're just sitting still with your eyes closed. Those thoughts will keep surfacing in the brain over and over again. That is, you can see that I am continuously processing that kind of information. So, in this state, although we may not know exactly what the content is, you can see that it's not a comfortable or relaxed state, but rather a very tense, anxious, or stressed state. If this SEF 90, that is, a state of very high brain workload, continues for a long time, Not only does it make you more vulnerable to stress, but it can also cause sleep disorders and even severe headaches like migraines. Next is mental stress. When your brain is extremely tense, anxious, and restless, this mental stress value appears high. For all of our indicators, the most important thing is that being in an optimal state is the most ideal. And when those indicators are either too high or too low, that's when you need to pay attention and take another look. So, if this mental stress indicator value is excessively high, it means we may be exposed to such stress for a long period of time. In those cases, things like anxiety, obsession, and post-traumatic stress disorder often cause this mental stress indicator to show up very prominently. So in these situations, it's essential to check and manage the mental state of the brain. On the other hand, when this mental stress indicator value is very low, remember earlier we looked at the brain workload? The SEF 90 value. That value is also partially reflected in our mental stress indicator. Therefore, when this stress, mental stress, value appears very low, it could of course mean you're in a comfortable and stable state. But because brain activity is showing up as extremely low, it could also indicate depression or a lethargic state where brain activation has dropped. Yes, next is the attention index. We create the attention index using the value of low beta plus mid beta divided by theta. That's how we derive it. This kind of concentration index can be used to evaluate overall attention ability, including the capacity to pay attention to surrounding situations and the ability to focus deeply on specific targets. So, as with the attention index, the higher it is, the better, and maintaining it at an optimal level is the most ideal. Therefore, being able to keep your concentration steady throughout the measurement period means you can maintain a sustained attention state. As you can see in the graph, the difference between the highest and lowest points isn't that big, and the level is being maintained quite consistently. In cases like this, it means that your sustained concentration is in a good state. However, even if the attention index results here are very good, for example, the graph could show very high and then very low points, or it could fluctuate between high and low, appearing in this kind of pattern. Even in these cases, since this index is derived from the overall average value, it might appear high, but if the attention index values are fluctuating and unstable like this, sustained concentration does not occur, so there can be cases of distracted attention. Now, generally, we divide our attention indicators into these 7 categories. So, the distracted type refers to cases where the concentration level is lower than the standard range. However, as I just mentioned earlier, there are cases where the standard concentration index is generally low, but also, when the graph is drawn in a very unstable way like this, it can also be considered distracted. The opportunity type is when the concentration level is lower than the standard range but occasionally spikes intermittently. The rabbit type, yes, this one uses an animal as a metaphor. You're probably familiar with the rabbit from fairy tales. In this pattern, concentration is strong at the beginning but gradually decreases toward the end. When this happens, we call it the rabbit type. In these cases, when faced with a new environment or when processing information, you may be able to focus quickly, but it can be difficult to maintain that concentration for a long period of time. So for people with this tendency, For example, when studying, it can be much more effective to break up study sessions rather than sticking with one subject for a long stretch without a break. The turtle type refers to people whose concentration levels tend to increase as time goes on, rather than being high at the beginning. In other words, you could say they have strong endurance or staying power. In these cases, rather than quickly adapting to a new environment, when exposed to something new or unfamiliar information, they tend to hold back at first, and then as they become more familiar and understand the information better, their concentration increases. So in these cases, rather than constantly switching to new environments right away, it can be much more efficient to finish one task completely before starting something new. Next is the focus type. We refer to someone as a focus type when their concentration falls within the standard range and remains steady. Also, the overfocus type is when the level of concentration stays at its maximum throughout the entire measurement. In these cases, this excessive focus can sometimes appear as a form of overimmersion. The typical type refers to cases where characteristics of all types are mixed together. The most ideal situation is when concentration is consistently maintained within the standard range. Next is the imbalance between the left and right brain. It refers to the brain imbalance value. We've said that, in our brain, the balance between the sympathetic and parasympathetic nervous systems is very important. Our brain has a left hemisphere and a right hemisphere, and between them is the corpus callosum. Likewise, the balance between the left and right brain is very important. So, we derive this imbalance value based on the relative activation ratio of the left and right brain. Again, being in a balanced state is probably the most ideal. So, if the results are skewed to one side for a long period of time, and there is a severe imbalance on the right side of the right brain in the overall brain waves, depression can increase. Also, when the alpha power in the left brain is dominant as shown in the given diagram, and the beta power in the right brain appears very strongly, this is one of the representative indicators of depression. Additionally, this kind of imbalance can also occur depending on our study or work habits, and how we use either the left or right brain. Generally, it is considered most ideal to use both the left and right brain in a balanced way. So, this pie chart is also one of the most representative indicators we use to look at depression markers in the brain. Next, finally, we have the intrinsic rhythm. The intrinsic rhythm can vary somewhat depending on age. For people, there is a dominant frequency that appears most prominently among the brainwave frequencies. That frequency is called the intrinsic rhythm, and in normal adults, it mainly appears in the alpha power range. Ideally, the peak frequency of the intrinsic rhythm, the point where it is highest, should be around 9 to 10 Hz. However, in the case of 8-year-old children, the dominant frequency often appears as a peak frequency around 8 Hz, which corresponds to the theta power range. This intrinsic rhythm can indicate the activation state of brain function as well as the state of cognitive function. Therefore, by observing the intrinsic rhythm in brain waves during the background state, that is, the default mode state, it is possible to predict the likelihood of Alzheimer's in elderly individuals at an early stage. There are already many research papers published on the relationship between this intrinsic rhythm and the possibility of dementia, in other words, the decline of cognitive function. Therefore, the intrinsic rhythm is generally extracted as the peak frequency in the range of 5 to 13 Hz. So, in the example file provided here, you can see that it appears very prominently and ideally at the 10 Hz mark. However, the theta power over here also appears somewhat high, and it would be better if this value were a bit lower. So, the position of this intrinsic rhythm tends to appear higher like this even when you're tired or somewhat stressed. Therefore, in children and adolescents, or when brain development is slow for their age or cognitive function is lower, the value of the intrinsic rhythm appears lower. As I mentioned earlier, in adults, the intrinsic rhythm appears around 9 to 10 Hz. However, even in adults, if there is excessive stress or if the brain's functional activity decreases, it can show up at a lower Hertz than around 10 Hz, and instead of appearing sharply and dominantly, it may show up in a more vague, rounded form like this. And in the case of elderly people, as I mentioned before, due to the decline in brain function and cognitive abilities, the frequency of this intrinsic rhythm can sometimes appear below 9 Hz. However, even for elderly people, if they manage their brain health well and experience normal, healthy aging, the intrinsic rhythm peak still appears around 9 Hz. However, for seniors who are around 80 or 90 years old, the position of this intrinsic rhythm can drop to around 8 Hz, similar to that of children. In such cases, it can be seen as a sign that normal aging is occurring properly. However, if the peak frequency of this intrinsic rhythm appears at a very low level, such as around 6 Hz or 6.0 Hz, it should be carefully monitored and managed in relation to cognitive decline. When it drops this low, mild cognitive impairment may be observed. Also, if this peak frequency value is high, in the case of children and adolescents, it may indicate that their brain development is somewhat ahead of their peers. It can also suggest a tendency for higher brain activity when using their brain. Similarly, for adults and the elderly, it can be seen as a sign that their brain function is active, their cognitive abilities are superior, and they are utilizing their brain efficiently. Yes, that concludes our review of the pulse wave measurement results and the brainwave measurement results. Thank you all for your hard work. Thank you.